Good morning. First of all, I'd like to thank all members of CISTI 2021 organization and everyone presented here to listen to the next few minutes of this presentation. I will share with you the details for the paper entitled OntoDRE, an ontology for the requirements engineering decision process, developed by me and my advisor, PhD Rogéria Cristiane Gratão de Souza. My name is James, and you can find some other information, including links to all my social networks and email, using the QR code on the slide. I will leave it here for anyone that wants to scan it while I present myself. My email is here too if you want to send direct email to me. I'm from Brazil, currently living in France, and I'm part of a research group named JEPIS that does some work mainly in software engineering and related subjects. This work that I'm presenting here is the partial result of my master's degree research. Here is a quick overview of the main topics of the presentation. I will start with an introduction to requirements engineering and decision support systems, following with a very short explanation about the semantic web, to finally present the development of the ontology itself. Let's go. To start this introduction, I chose to present here a quote from Frederick Brooks, that is famous for his book The Mythical Man Month. He says that Einstein repeatedly argued that there must be simplified explanations of nature, because God is not capricious or arbitrary. No such fate comforts the software engineer. And I chose this quote because it represents a good way to explain for anyone the difficulties of software engineering. How hard it is to create software, and how specifically how much the requirements engineering are essential for the process of create software. After Mr. Brooks, we can say that no software is simple, and controlling this complexity is part of the requirements engineering. Is an essential part of the requirements engineering. An essential product of the requirements engineering process is the decisions taken during all phases of software creation. Almost all professionals will agree with it. Despite this importance, we can't find any formal modeling for the decision process during the phase of software development. For sure, the decision process itself is formalized in many forms, but here we want to achieve a specific formalization for requirements engineering that could be used to reason on decisions in decision support systems, also named DSS. In the slide, we have a very simplified scheme for a DSS that shows clearly that a DSS is composed of a database management system, a classical database, SQL or not SQL, this does not really matter, and also a knowledge base, a knowledge database that could include a model database to formalize the decision process. I'm saying decision process here, but the model database can formalize any process. I'm just interested in the decision process itself. So it's here where an ontology that formalizes the decision process in requirements engineering should be used. Now, why we decide to use an ontology instead of any other formalization tool? We decided to take the way of ontology creation because of the possibility of the semantic web. According to W3C, the World Wide Web Consortium, the semantic web is the stack of technology that could enable people in the new use of their data around the web, including the use of intelligent agents that can perform automatic actions on their data to deliver better services and improve the use of the web itself. These concepts and technologies are powerful, and they will change everything that we know about the web in the next few years. So it's important to create vocabulary, to create ontologies for this word, this future word. An essential part of the semantic web stack is the ontologies. According to Guarino, an ontology is a set of concepts and terms used to describe a certain domain which is related by relationship attributes. Although this definition looks simple, ontologies are a key concept of the semantic web, since they create the basic vocabulary that should be used for other tools for reasoning about the domain that the ontology itself formalizes. In the context of requirements engineering and decision support system, we have some ontologies, but we do not have any ontology to deal specifically with decision in requirements engineering, which brings us to the necessity of OntoDRE creation. The purpose of OntoDRE is to formalize the concepts of decisions in requirements engineering, allowing the use of this vocabulary in the context of the semantic web. It enables the use of automatic actions in the requirements engineering tools and around the web itself, if OntoDRE is used in any website or any web system in the future. The methodology adopted for OntoDRE creation was an adaptation of the Sabio methodology. That's a methodology based on proposed definition using competence questions. In the slide, we have a schematic diagram to show how the methodology was defined after Sabio definitions. After proposed definition, in step 1, we have a cycle process that includes ontology capture, reuse, and formalization, always backed up by documentation. The main formalization tool used to create OntoDRE was first-order logic in the form of 5 axioms. The following slides present each one. They are all implications that establish some relationship between requirements, decisions, and knowledge management artifacts. The axiom 1 shows the relation among requirements and projects to establish a decision situation, to establish what is a decision situation. The axiom 2 establishes the relations that define which actor, and which actor I mean developer, stakeholder, manager, anyone interested in the software creation, that we act in specific requirements. Because the actor that defines the requirement could not be the same actor responsible for its evaluation. The axiom 3 is important by defining an interdependency rule for the requirement dependency. Axiom 4 defines the commutative property among requirements with conflict. And finally, we have an axiom exclusively to establish logical rules between requirements and artifacts of knowledge management. So the actors can act on requirements to define actual decisions. The knowledge management as a process of decisions documentation is out of the scope of OntoDRE, is out of the scope of this paper, although it includes relevant concepts to be considered in future works and in a broader context for the semantic web. For the documentation, we also, besides the axioms, we also use some graphical tools like adaptation of UML and the OnVis, that's a tool used exclusively to document ontologies. For OntoDRE evaluation, we use a methodology composed of 3 basic steps. The manual evaluation using the Gruber criteria that enables us to ensure the quality of ontology based on 5 widely known criteria for ontology evaluation. The automatic evaluation using a tool named OOPS, which is a web tool that receives the ontology file, writing all, for example, OWL, as input, and shows a very good quality report, allowing the ontology creators to evaluate some common fails and drawbacks in ontologies. We also include a third-step evaluation, that's a very important third step, in a form of a proof of concept. This final step ensures that OntoDRE was correctly designed to be useful in the context of utilization in a real web environment. For it, we use a previously developed requirements engineering support tool named REST, developed by as a web tool, and with the application of OntoDRE, we can include a few decision support features. This proof of concept is enough to show the possibilities of OntoDRE utilization as an application ontology in DSS systems. For the conclusion, we can say that our main objective for OntoDRE was successfully achieved. We aim to cover the lack of formalization for decisions in requirements engineering, and we choose to achieve it using a formal ontology to allow its use in a semantic web context. We create the ontology named OntoDRE using a methodology for ontology creations. We evaluate this ontology in 3 steps: manual, automatic, and also as a proof of concept in the context of semantic web for a tool, for a GSS tool, for a decision support system tool. And so we can conclude that our main objective was successfully achieved. I'd like to thank you to everyone again, and I'm open to any questions in my email for anyone that wants to contact me. Here is a short bibliography that includes all the works of the papers that I cited in this presentation. Thank you again.